Welcome back to the third video in our series on database system concepts and architecture. In this episode, we're going to spend a good bit of time talking about schemas. So for this lecture, why don't we just make schema our mystery word? Let's get started. In any data model, it is important to distinguish between the description of the database and the database itself. The description of the database is called a database schema. Database schema is a description of the database, which is specified during database design and is not expected to change frequently. Most data models have certain conventions for displaying schemas as diagram. That displayed schema is called a schema diagram. So the description of a database is called the database schema, and the displayed schema is called a schema diagram. We call each object in the schema, such as student or course, a schema construct. So we have a database schema that is shown as a schema diagram, and each object in that schema is called a schema construct. A schema diagram displays only some aspects of a schema, such as the names of the record types and the data items, and some types of constraints. Other objects are not specified in the schema diagram. For example, it would not show the data type of any data item or the relationships among the files. Many types of constraints are not represented in schema diagrams. The data in a database at any particular point in time is called a database state or a database snapshot. It is also called the current set of occurrences or instances in the database. You should notice in this example of a schema diagram that there are 5 schema constructs showing a number of attributes in each one. You'll also notice that there is no information about the data type, size, or anything else about each of these parts of the construct in the schema diagram. The distinction between a database schema and a database state is very important. When we define a new database, we specify the database schema only to the database management system. At this point, the corresponding database state is an empty state with no data. We get the initial state of the database when the database is first populated or loaded with initial data. That could be when the first user inputs a record from a GUI client, or someone runs a script that inputs a number of records at once. In our labs, we will be doing this kind of a thing. We will be writing scripts to upload data into our databases. From then on, every time an update operation is applied to the database, we get another database state. The database management system is partly responsible for assuring that every state of the database is a valid state. That is a state that satisfies the structure and constraints specified in the schema. Therefore, specifying a correct schema to the database management system is extremely important, and the schema must be designed with the utmost care. The database management system stores the descriptions of the schema constructs and constraints, also called metadata, in the database catalog or data dictionary so that the database management system software can refer to this schema whenever it needs to. In most cases of applications created in the database environment, it's highly unlikely that the schema we design today will never change. Requirements for most applications will change, and the specifying database schema must change with them. This change in the schema is referred to as schema evolution. Now let's talk a while about three-schema architecture. In this architecture, schemas can be defined at the following three levels. The internal level has an internal schema, which describes the physical storage structure of the database. The internal schema uses a physical data model and describes the complete details of the data storage and access paths for the database. The conceptual level has a conceptual schema, which describes the structure of the whole database for a community of users. The conceptual schema hides the details of physical storage structures and concentrates on describing entities, data types, relationships, user operations, and constraints. Usually a representational data model is used to describe the conceptual schema when a database system is implemented. This implementational conceptual schema is often based on a conceptual schema design in a high-level data model, such as the ER diagram. The external or view level includes a number of external schemas or user views. Each external schema describes the part of the database that a particular user group is interested in and hides the rest of the database from that user group. As in the previous level, the external schema is typically implemented using a representational data model, possibly based on an external schema design in a high-level data model. The three-schema architecture is a convenient tool with which the user can visualize the schema levels of a database. Most database management systems don't separate the three levels completely and explicitly, but support the three-schema architecture to some extent. The three-level ANSI architecture has an important place in database technology and development because it clearly separates the user's external level, the database's conceptual level, and the internal storage level for designing a database. Notice that the three-level schemas are only descriptions of data. Stored data that actually exists is at the physical level only. In a database management system based on the three-schema architecture, each user group refers to its own external schema. The database management system must transform a request specified on an external schema into a request against a conceptual schema, and then into a request on the internal schema for processing over a stored database. If the request is a database retrieval, the data extracted from the stored database must be reformatted to match the user's external view. The processes of transforming requests and results between levels are called mappings. These mappings may be time-consuming, so some database management systems, especially those that are meant to support small databases, do not support external views. Even in such systems, however, a certain amount of mapping is necessary to transform requests between the conceptual and the internal levels. Well, we've got quite a bit to chew on as a result of this video. So why don't we just take a break here, go out and answer our mystery word, and then go to coursework and check my knowledge on the material that was covered. When you're ready, come on back and we'll proceed to lecture number 4 in this series.